Hi, good to see you all. Welcome to another chemistry class. I hope you're all safe out there. May God be with us all. Okay, today we'll be talking about chemical combination. That is how elements combine with one another to form a suitable compound. Now, usually under this topic, we have two concepts. We're going to be talking about the electrovalent combination and the covalent combination. Now, this electrovalent combination involves the transfer of electron from one element to another element. Now, in chemistry, our plus sign is different from the normal addition sign. When an element carries a positive sign, it simply means it is giving out electron. It is giving out electron. Whereas if an element carries the negative charge, it is what? Accepting electron. Positive, give out, negative, accept. It is different from the usual thing we come across in mathematics. In mathematics, you know that plus simply means addition, but it is different in chemistry. You are not adding anything to your number of electrons. So for a positively charged element, it simply means it has given out its electron. So if you have an element that has plus 1, it simply means it has given out 1 electron. Plus 2, it has given out 2 electrons. If you have an element that has minus 1, it has accepted 1 electron. Minus 2, it has accepted 2 electrons. So that's the difference between the charges. Now, under the electrovalent combination, it is usually between a positive element and a negative charge. Yes, a positive charge and a negative charge combined together to form electrovalent combination. Because one has to give out, the other has to accept. Giving out plus charge, accepting negative charge. Is that understood? Okay, now let's look at this electrovalent combination. For example, sodium chloride. If you are given a compound, the first thing you have to do is to analyze the elements that constitute the compound. Sodium chloride. So we have sodium here, we have chlorine here. Sodium has this electronic configuration 281. Chlorine has 287. So it is possible, invariably, sodium will have to give us this plus, this 1. And that is why it's having the plus. While chlorine will be accepting 1 from the sodium to fill the 7 and make it what? 8. The ideology under this electrovalent combination is for you to maintain a duplex or octet configuration. That is, your last number here must be completely filled and ends with figure 8. So if chlorine accepts 1 here, that means this one will have 288. And sodium would be what? 28. So here now it shows that sodium has given out 1 electron. This is the electron, transferring the electron to chlorine that has 1, 2, 3, 4, 5, 6, 7 outside. So here, sodium becomes 28 and chlorine becomes 288 outside. So because this one is plus 1, chlorine is minus 1, once they cross like that, it becomes sodium chloride. NaCl. NaCl. The minus 1 goes like this, the plus 1 goes like this. So it is balanced. Now let's look at this one. Magnesium chloride. Magnesium chloride. Let's first of all write the constituent elements, which is what? Magnesium and chlorine. Now, what is the electronic configuration of magnesium? We have 282. Usually 287. Now, looking at this one has 2 electrons to be given out. So we are going to have Mg 2+. Meanwhile, chlorine is 287. If chlorine accepts 1, what about the remaining 1 for magnesium? So here we'll be having 2 molecules of chlorine. We have 1 chlorine and another chlorine. So that if this one attracts 1, this one to attract the remaining 1. Now let's go up here. Let's write it out. Our magnesium is what? 2 8, and we have 2. 1, 2. Are you getting me? Our chlorine, we have 2, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. That's for the chlorine. So here 1 goes to meet this one here and pairs up. Or let me just use this one. While the other one goes to meet this one and pairs up. So our resulting magnesium will be what? 2, 8. While the chlorine will be 2, 8, 8. 2, 8, 8 and another 2, 8, 8. So remember, chlorine minus 1. If it goes to meet magnesium, the 1 goes to meet magnesium, while the plus 2 for magnesium goes to meet chlorine, and we have 2 here. Which shows that we have 2 atoms of chlorine combining with the magnesium. So if we want to write the formula, this is how you write it. Magnesium chloride. Now let's look at the last one, calcium oxide. So for calcium oxide, it involves calcium and oxygen. Calcium has electronic configuration of 2,8,H2. Oxygen has 2,6. So now, if this one is giving out the 2, it simply means Ca2 plus. While oxygen is what? It has to accept the 2. Is that taken? That means oxygen will have to accept the 2. So now, let's write it out. We have 2, 8, 8, then 2 outside. Oxygen, 2, and 6. 1, 2, 3, 4, 5, 6. So if this one goes like this, transfers it to oxygen. So calcium will be left with what? 2, 8, 8, and oxygen becomes 2, 8. So once they combine, this one is minus 2, goes to meet this one. This one is 2, goes to meet this one. So it is balanced. Calcium oxide. So that is how we write combinations involving electrovalent bonding. Just have it at the back of your mind that electrovalent bonding is transfer. It's transferring electron. One will be accepting, the other will be what? Will be giving out. The one with a positive charge is the one giving out. The one with a negative charge is the one accepting. All right, see you again next class. Bye. Ciao.